Alright. At noon, ship Q is 200 meters south of ship P. That was a very standard per day, if I'm being honest. That's bread and butter usually. Ship Q is south of ship P. You're P, you're Q. And you are a distance of 200. Happy days. Okay, ship P is travelling southwest at 24 route 2. Happy days. Ship Q is travelling due west at 17. They're giving us all the information and they're telling us what to do. They didn't give us a choice. You could use VPQ or VQP because they're both vehicles, aren't they? So you're allowed to use either one. So as it turns out, they want us to hold P is now stationary, and what way would Q move relative to P? So we write down VPQ, VQP is VQ minus VP, and VP on its own is VQP plus VP. Happy enough with that? Okay. I'd go through my usual magnitude direction scenario again. Okay, and I would say VP equals VQP. Just give me a sec. Q relative to P is VQP. VQP is VQ minus VP. Bring the VP over the other side. Oh, I have two VPs. I see the issue. That's a VQ. Thank you. My Q looked a lot like a P. That is confusing. Thanks for that, Michael. That's not a minus. We all good? Okay, what do we know? Does it intercept it? Probably not. Okay, so we probably don't know that much, right? So let's see what we do know. I think ship P might be too fast for it, or signals. I don't think it catches it. Sure, we'll figure that out in a second anyway. Alright, so what's VQ? It doesn't say intercept course, does it? If it doesn't say intercept course, then you can't really assume there's an interceptor, right? So, what's VQ? 17, and where's it travelling? West. Okay. VP?
24 2.
Yeah. And where's it going? Not southwest, right? Is that 4 pieces of information?
Yeah.
Should be doable. Alright, so let's get this, let's try and picture it in our heads here. VP is moving southwest. There's VP there. VQ is we have no option on where Q is going, do we? It's just travelling west. That's the issue there. It's travelling west, and it isn't going out of its way to intercept P. It's stuck going west anyway, right? So we want to see how close one of them gets to the other one, is basically what we're looking at. Okay? Now, the real challenge here is trying to figure out what direction you think VQP is going. So imagine Q is stationary. What do you think is happening here? If you aren't too sure, you could do this very easily, right? You could use VQP. You can figure it out straight away, can't you? So what is it? VQ minus VP, no bother. What is VP? Southwest, right? So this would be one where I might change back to the vectors, just because I think it's going to lend itself to it. Yeah. So that's 24 root 2. So what will the two of these be? Just 24s, won't they? It'll be 24 cos 45 and 24 sine 45. Oh, sorry, 24 root 2 cos 45 and 24 root 2 sine 45. But we thought now the deltas turn into 22s. Oh, sorry, 24s. Alright, so that's 24i minus 24i minus 24j. Is that alright with you guys? 24i, 24j. So that is VP 24i minus 24j. Right, this question is actually quite easy. VQ is minus 17i. Happy days. Alright, let's do VQ minus VP. Yeah. Minus VP. J. Now what do we get? 7i plus 24j. Is that alright with you guys? Now, if we go back to our starting off diagram, and we said that which one's south, which one's north again? Q's on the bottom, P's on top. Q, P. We said that P is rooted to the spot. Happy days. And now we know that it goes across at 7 and up at 24. Across 7, up at 24 is a pretty sharp angle. Okay with that? Now, what angle would it be? So, what is 7 across 24 up? What is the angle? Call it tan x. Will somebody get me tan x, please? 25 for the hypotenuse, and you could figure it out that way as well. That sine x would be 24 over 25, and cos x would be 7 over 25. You can use the angle if you want, but it might not be necessary because you already know what tan x, sine x, and cos x actually is. All right. What I'm going to do first is I'm going to figure out the closest approach. Now. What were their initial distances apart? Lads, can somebody tell me how far apart they were at the very beginning? 200. What? 200, right? Sorry, no, that's slightly too large. Alright, if they're 200 apart at the very beginning, and how long can they exchange signals for? So, for argument's sake, this red line here, is when it's 119 away. So does everybody see that Q is moving relative to P? Q is represented by this yellow dot. This yellow dot moves along this line when P is held stationary. It was 200 meters away, and it gets closer and closer and closer until it reaches a distance of 100 and. Then it can exchange signals. It keeps traveling closer and closer to P. That point is the closest distance. Then it travels out the other side until it's 119 meters away. So what you want to do is, first things first, we're going to calculate the closest approach. We're going to calculate this guy here. So how do you calculate him? Anybody know how to calculate D? Sine x equals what, guys? D over opposite over hypotenuse? 200. D over 200. And what is D going to be then? It's going to be 200 by 24 over 25, apparently. What? 192. That means it never gets within 119 kilometers of each other. Alright. Sorry lads. Opposite over adjacent. So what do you say I have as? So 7i, which is 7, 24. Alright lads, I'll come back to this one tomorrow. Okay gents, so just continuing this question on from earlier, that we found out that D was way too big at 192. It's because I actually made an error with this angle X. Angle X is actually this one here. Okay? So that's actually angle X right there. Alright? So, and angle X, as we said earlier, was angle X was shift tan inverse 24 over 9, which is 69.44. But take that away from 90 degrees and we get 20.56. This here is 20.56 degrees actually, lads, alright? So I was actually using the wrong, as Connor alluded to, I was using the wrong function, alright? So P it's no longer sine X, it's sine 20.56. And that's going to be 200 times 20.56. Because remember, sine X earlier was, sine X is this angle here where you're going up at 24 and across at 7. That made that 192 way too big. Okay, so what we're going to get now instead is 200 sine 20.56, which is a 70.24. And 70.24 is a much better size, right? Now, zooming in on this triangle here now, or I'll just redraw it, okay? So we now know that this starts off here, alright, and this is P, this is Q, alright, and Q travels towards P. It's a gap of 200 at the beginning, and then it comes a gap of 70.24. And in between these two, there's going to be a gap of 100 and there's going to be a gap of 119, okay, which is here to here. Okay, now this 119, okay, and what we can do here is we can do Pythagoras' theorem. So let's get rid of that. So if we do Pythagoras' theorem like so. And what I'm going to do with Pythagoras' theorem is I'm going to figure out what is this little part here. Okay? So it's going to be 119, and that's going to be 70.24, and this is going to be x. So we'll just say that 119 squared equals x squared plus 70.24 squared. And I'll just get x on its own really quickly. It's 119 squared minus 10.24 squared is that number there, square root it. It's actually 118.56. Now this yellow distance is only half the difference, so we're going to have to do all the distance, because remember, Q is 200 meters away from P, or 200 kilometers. It then travels to within 119 where it can start using the signals. Then it gets even closer to P when it's 70.24 kilometers away, and then it goes all the way up to it travels by that point, because this is Q moving relative to P. Okay, so this is Q moving relative to P, and it travels by that point and then all the way up. Okay, so next thing we're going to do is going to multiply this by 2 to find out the total yellow distance. Okay, and then it's 273.12, this entire yellow distance. Now, what speed is Q going relative to P? Well, if we go back to our triangle here earlier on, it's actually going at a speed of 25 relative to P. Right, so it's getting a speed of 25 relative to p because it's going across 7 up 24, which is across at 25. So if I divide this answer by 25, that will give me the time taken, because the question is after if the ships can exchange, it says find the amount of time they can exchange the signals for. The amount of time they can exchange the signals for is your distance travelled, distance divided by speed, which is 273.12 divided by 25. About 9.5 hours or 9.48 hours. Okay, I believe we have the solutions here. That's not great. Okay guys, so if we think about this right here, it's 7 across and 20. Okay lads, so when you think of 7i plus 24, okay lads, so when we think of 7i plus 24, what we're thinking is 7 across and 24 up. So 7 across and 24 up. Okay? So it's 7 and that's 24. Okay? And that's, for argument's sake, angle x. Alright? If we do the hypotenuse of this, it means 25. Okay? So this means that Q is moving relative to P in this direction here. Q is actually moving upwards in this direction relative to P at an angle of x. And if that's 90 degrees and x plus y equals 90 degrees, that means this is also angle x is up there as well. So we know that angle x is up here in this triangle here. Okay? Now, if we take this diagram here, like so, alright, and we just sort of make up a rip-off version of it, like so. I'll bring it down slightly. Okay, so what we had at the beginning was P is here, and this is Q. They're a distance of 200 apart, and they're moving in the directions shown in green on the left. Now, because P is held stationary, because it's phi PQ, or sorry, phi QP, this means P has been held stationary, and what's happening is Q is moving at 7i plus 24j relative to P. So it's moving up in this direction here. Okay? Now, so it starts off at 200, and what we're going to do first is we're going to figure out the closest approach, which is generally 90 degrees from its original, like so. 90 degrees. So what happens here is the following. Q moves from a distance of 200 all the way to its closest approach relative to P. Okay? And what we're going to do here is we're going to use angle x from the previous. So we're going to say that we learned earlier that tan x is 24 over 7. That means cos x is, what's it, 7 over opposite over adjacent, so 7 over 25. And then sin x will be 24 over 25. That's because it's 7, 24, and its speed, the speed of Q relative to P is 25. So this Q is travelling at 25 kilometers per hour relative to P. So is that 25 kilometers an hour relative to P. Now what we're going to do is we're going to calculate the value of d, which is the closest distance. So what we're going to get here now, if this is angle x and that's angle y, and angle x plus angle y is 90 degrees, this means up here has to be angle x as well, because x plus y have to equal 90. Okay? Now that we know that that's angle x up there, what we can say about d here is that cos x equals d over 200, and then d equals 200 cos x, and 200 cos x is 200 multiplied by 7 over 25 by 7 over 25, 56. So d equals 56, okay? Now that's not what we're being asked to do. We now know that that's 56, happy days. But what we want to know is when is q within 119 kilometers, okay? So what we do next is this is 119 kilometers, and then out the other side is 119 kilometers as well, okay? So what we get here is the following. So let's get rid of all this for a minute. So I'm going to use Pythagoras' theorem to calculate out what is the length of this line here. I'm going to calculate what this line is here using Pythagoras' theorem. Okay, and we know that the blue line here is 119. This blue line is 119, so it's essentially 56 and 119, and we want to figure out this distance d. Okay, so 119 squared equals 56 squared plus d squared, so it's going to be 119 squared, take away 56 squared, and square root that to get d. D is 105. Now, if this distance is 105, we double it to get 210, because 210 is how far it has to travel. That wasn't my best move. 210 is how far it has to travel. So Q hits 119 kilometers away from P, travels along this distance. So Q hits here, continues along all the way to the end. Okay, so it's 119 kilometers away, then it's 56 kilometers away, and then it's another back to 119 kilometers away. So it's traveling along this line relative to P. So that means it travels an entire distance of 210, and as discussed earlier, it's going at a speed of 25. 210 divided by 25 is 8.4, which is exactly the time we need. T equals 8.4 hours. Okay guys, that's it.